Hello everyone, David Blakey here. This video is entitled Python Set. I put the parentheses after a set for a particular reason. What is a set? Let's look at the handout. Set is the third function or the third container that I have listed in the handout. I used to have it later in the handout as not part of the main built-in structures, because in a sense it isn't a built-in structure. I mean, it's built into Python. It's certainly available at any time, but it doesn't have its own special constructor brace. A list, for example, this is a list right here with the square brackets. A list has its own container brace. We can construct a list this way. We can construct a tuple this way. But if we want to construct a set, we have to use the set function. And even then, we have to pass it some other form of sequence. For example, we could pass it a list in situ, literally in the argument, or we could even pass an existing list that is labeled to a set. And what we'll get back then is a set. When we print it, you can see it looks very much like the way we might construct it. We get back a set with the parentheses, and then inside it, the list that we passed into it. But you may notice something very interesting about the list that we passed into it versus the list that we find in the set, and that is that the elements in the set have been reordered. We put them in as MyList, and MyList, of course, had three elements in order of some alphabetical order, A, B, and C. Yet the set has it in a different order. Why would that be? Well, it's one of the characteristics of a set. A set does not have a guaranteed order, which of course means that we can't use a subscript with a set. If we tried to take subscript 0 of the set, Python would give us a problem. Set object does not support indexing. Why doesn't it support indexing? Well, it doesn't guarantee any sort of order. These elements could be reordered again if we added another element or two. Why don't we do that just to see what happens? MySet.add does not use append the way that list does. And one very good reason for it not to use the word append for its adding function is that append means add to the end. And since we don't know where these elements are going to be added, append would not make sense. Let's print my set. Whoops. There we go. A, C, B, E, D, F. All foobarred up. There's no set order to a set. There's another aspect to a set that makes it very different from something like a list. You can add elements that already exist. See, I'm adding A and B here. And interestingly enough, the list doesn't seem to change at all. Let's just add one more element that doesn't exist to make sure that we're doing everything. We're not. See, just as a side note, anytime that I see the same output twice, I wonder whether I even saved the program and Python's actually reading the new revision. Well, Z got added in this example. Let's run it again. Z was added, but any of the A and B were not added. You can see that A, B, and C went into the original list, and then when we added A and B again, there was no effect. I can drive this point home just by, let's say, adding F a bunch of times. I'll put in ZZ or XZZD here just to show that Python took the changes. There's XZZD, and you can see I added F about 20 times, and there's only one F. So why is that? Well, it's the second aspect of a set that makes it very different from a list, and that is that a set has unique elements only. There's no duplicate elements in a set. So the two aspects that make it very different from a list are there's no guaranteed order of the sequence, and there are no duplicate elements. So a set's a strange sort of animal when you consider an ordered list, which makes the most sense. Why would we want to work with a set that has no guaranteed order to its elements and has only a unique set of elements? You can't have any duplicates. Well, precisely because we might want to have a unique list of elements. That's something that's quite common operation and common need in computer science. We want to create an algorithm that just creates a unique list of something. For instance, we might be going through a data set. In your homework, you're going through a data set and finding a unique list of states. That's something we often want to know. What states are represented in our employee pool? They're from New York and New Jersey, surely, but are there any from Pennsylvania, any from Ohio? Can we get a unique list of all these things? Maybe you'd like to get a unique list of IP addresses that address your web server, just to get a full range of IP addresses. Or maybe you want a set of unique dates that a group of requests came in. There's always a need for unique set of items, and then that's where a set would come in. But also, in addition, some things we're not going to go over so much. Set has a number of attributes that allow us to compare one set to another. I'm going to open up the interactive interpreter and do a dir set to see what we get. Intersection is one. Difference. Sets allow you to very easily compare two sets, and find out the difference or the intersection between them. Difference would be elements that don't occur in one list that do occur in the other. Intersection might be, I believe, which elements are common to the two. Is superset might ask, is one list entirely contained with another list, or is one list entirely contained with the other list, or vice versa? So that's one of the other uses of sets. For our purposes, we're going to be using a set to create a unique list, and it's very handy for doing that. We can also cycle through a list in the same way that we might any other sequence. And of course, we can use the same operators that are available in with the other containers, namely for, in, and len. So we can say for I in my set, print I. We can say, why don't we just say A in my set? Let's print that, print A in my set. And then let's, another print statement. And then let's print len my set. So we're going to get a loop of all the elements in my set. We're going to see if A is in my set, and we're going to print len my set. So we get A, C, B, D. Again, the order is whatever Python decides is best. We find out that A is in my set, and we also get the length of my set. Another important benefit of a set, and the reason why the elements are not in any guaranteed order, is that if we were to sort the set, or if we were to look up an element within the set, we might want to see if, let's say, A is a member of the set. It's a lot more fast and efficient than using a list or a tuple. Lists and tuples are ordered in a particular, in a static and guaranteed order, the order that we place them in. And in order to do some sort of search to check for membership, Python needs to check each element in turn. May have some optimization that makes things easier for it, but when Python has the opportunity to order these elements any way it chooses, it can do a sort, and it also can check for membership much more quickly and easily because it knows something about the order of things, and it can make use deductive reasoning to figure out whether an element is in the set or not. So that is Python sets.